dances on my tongue, tastes like she might be the one. And I can never get enough. I could buy her so much stuff. It's a craving, not a crush, huh? Call me when you're there. I said I bought you something rare, and I left it under Claire. So now she's coming up the stairs, so I'm pulling up a chair. I could eat that girl for I could She's taking pictures in my mirror. Oh my God, her skin's so clear. Tell her bring it over here. You need to see I volunteer. Now she's smiling ear to ear. She's the headlights on the deer. I said it all before, but I'll say it again. I'm interested in more than just being your friend. I don't wanna break it, just want it to bend. Do you know how to bend? I could eat that girl for I could eat that girl for lunch. She dances on my tongue, tastes like she might be the one. And I can never get enough. I could buy her so much stuff. It's a craving, not a crush, huh? Call me when you're there. I said I bought you something rare, and I left it under Claire. So now she's coming up the stairs, so I'm pulling up a chair. I could eat that girl for
What is up, guys? Welcome to this evening's little stream. I'm just going to grab the live chat window, get that up and running. There we go. How's everyone doing this evening? It's fireworks night here in the UK, which is great. Hopefully that doesn't mean that we're going to see fireworks in the workshop. They'll keep them to outside. This evening on the bench, I have got a Sundown SALT12. Now, those of you who watch my streams regularly, the camera that's looking down here is different because my capture card for the JVC overhead cam that I used to use, actually I've got it right here. Where is it? You can see what I've been using for my overhead cam for years with great success up until now. It would still work. Is one of these little bad boys. So the beauty of having this above the workbench is that this has a optical zoom, so I can zoom right in on components without losing resolution, because it's got a big optical zoom, and it was just going out via HDMI to a capture card, and the capture card seems to be cooked, completely toasted. It was just a cheap capture card, but even though it was a very cheap Chinese capture card, it was actually the only one that I've tried that didn't have a horrendous amount of input lag. So I've actually got a decent, in inverted commas, Elgato gaming bloody capture card, HD 60 Pro, supposed to be really good. But whenever I use this, the input lag is horrendous, which means that I have to add a delay to all of my other sources in OBS. and then it's just kind of awkward to stream with because I'm like behind myself on the screen. It's just kind of weird. But this cheap Chinese capture card, I think it only does 1080i. It's not full 1080p, but it's good enough for these streams and no lag, so kind of frustrating. But so what I'm doing is I'm using the Logitech StreamCam, which is fixed zoom. So I've got a digital zoom on my foot pedal, which obviously crops in and you lose resolution and you can't see anywhere near as detailed as you could with the JVC, but hopefully that's good enough. And if I need to show something in very close detail, then I guess I can just grab it down from the clip. But anyway, how's everyone doing? The Salt 12 that I'm looking at right here, this is just the power supply section. This had a full power supply meltdown. All of the 7530 MOSFETs completely cooked. It killed all the gate resistors and it cooked all the drivers. This amp has 40 drive transistors. There's 40 individual drive transistors. Absolute pain in the butt to repair just because it's so time consuming. There's so much going on. You got 40 FETs, 40 gate resistors, 40 drivers. Now I found the reason why this amp went down, and now, like I said, I don't know whether this is going to really be made out on stream because I can't zoom in far enough. But essentially, there is this transformer has an auxiliary wind here for, now I don't know whether this side is plus minus 12 volts or the 12 volts ref negative rail, or plus minus 15 volts, but it has an auxiliary wind here that then appears to go off to the other board to get rectified by the looks of things. There are some components down here and around here, but yeah, I believe the rectification circuit for this is actually on the main board because I'm not seeing any rectifiers here just now. But there's a trace here that goes underneath this cap. And yeah, like I say, unfortunately, it's not very easy to see on this camera because I can't zoom in enough. But there's a trace here that goes underneath the cap, and that has been completely blown open. So I suspect if I remove this cap, I will find a blown open trace. I think this cap has shorted to the trace, and that then has obviously caused a short circuit on this transformer, which has killed one of these FETs, and then when these FETs are dead, they send 12 volts down the gate path and it's killed all the rest of them. Lovely. So I'm going to start this evening's stream by removing this capacitor to have a look and see what the trace looks like underneath. Cameron says, that's my amp. Well, this is actually your one that was sent in. Is this actually your amp? Well, at least you'll be pleased to know that it wasn't user error. Doesn't seem to be user error. No output side failure, just power supply. I mean, it could technically be a bit of user error because this kind of thing happens due to vibration damage. Like, oh wow. Actually, you know what? This cap is hella loose compared to the rest of them. So the rest of these caps are seated down, secured down really strong. This one is loose and it's actually cracked the casing here. You can't see it, but it's actually cracked the casing at the bottom there. So if this was mounted to a subwoofer enclosure, I mean obviously this is a big amp, so it's going to be a big build, then if that cap has vibrated and shorted out against the trace, then does that count as user error? Yeah, probably. Did you check trace continuity? There's no trace left. The trace is gone. I apologise you can't really see it on the camera because the camera's crap now until I get my new capture card sorted, but there used to be a trace here. There is no longer a trace there. It's gone, vaporised. Yeah, Chris brought it to you. Ah, fair enough. So yeah, all these ones came in through a good guy called Steve in the UK. He deals with Sundown stuff and alternators and that, and he arranged all of these. I've got a whole bunch of Sundown stuff come to. Well, at least we've got the customer in the live chat. We love to see it. I love it when that happens. At least we've got the client, the amp owner, in the live chat. What are the chances, eh? But yeah, I guess you'll be pleased to know that it wasn't anything that you did wrong, like setting the gains wrong, or like, you know, it wasn't that kind of user error. Vibration damage, technically maybe user error, but also the amp should really kind of be built stronger to deal with that. Yeah. Anyway, but the actual amplifier stage is fine. Now the reason that I started getting a bit suspicious about that trace there, because I've repaired the power supply section now basically. I haven't powered it up yet because I didn't want to power it up yet without going over the board and thinking to myself, why did this fail? Power supply sections on amplifiers don't fail by themselves. They don't just randomly fail. Output sections tend to do that. A lot more volatile, a lot higher voltage going on, lots of things that can fail, very, very sensitive or self-oscillating circuit, etc. But the power supply sections, low frequency, super reliable parts, they just don't fail by themselves generally. So when you've got a blown power supply section and the output section is fine, that's a bit sus. You're looking at it thinking, right, what's gone on here? What else is bad that's caused this? If you just repair the power supply, if you just fit new FETs, gates, drivers and send it, the amp's probably coming back to you because you've missed what the actual cause was. Now on the back of the board here, which you can just about make out on this camera, there is a trace here that is a different colour. Now this solder mask is brown, and this trace right here is rainbow colour, which again you can't really make out on this camera. I do apologise. It's awful, isn't it? I'll get the Elgato capture card connected for next time. But this trace is a rainbow colour, which means it's got hot. That has got absolutely roasting hot, that trace there. So I was like, that is a lot of current that's gone through there. So I looked on the other side of the board, and that's when I found a completely missing trace. So that's how I have come to. So I haven't powered this up yet after repairing all the power supply. Like I say, it's got 40 new FETs, 40 new gates, 40 new drivers. PWM from the TL494 is perfect. So this power supply section should work now once we fix the problem under here. Yeah, these amps. This is my problem. This is my issue with big Koreans, is that the circuit designs are all based on 20-year-old technology, and it's just basically been recycled and beefed up as much as it can with modern components, but the actual architecture itself has not changed, which is just dreadful. I mean, they're charging so much money for these. It is like the biggest money maker in car audio is these big stupid amps. Like if you get a Korean amp like this with one dead output MOSFET, let's say you just lose one output MOSFET because fuck it, like it was a weak one. You're not just lost one output MOSFET, you've probably lost a lot of other output MOSFETs because it spikes back through the drive circuit. That happens on all amps. But because these amps don't have any power supply current monitoring or protection mode or anything for that, the whole power supply section explodes. And then all of a sudden, your repair bill has gone from, like, I don't know, a big amp like this output section rebuild, maybe like 200. Your repair bill's gone from 200 to a full rebuild, which is like 600 plus. This is not the case for this amp because the output section is fine, but I'm just saying, because these amps are designed like freaking 20-30 years ago essentially, they're dumb. They don't have any protection. Whereas a Brazilian amplifier, for example, like a Taramps amplifier, the output sections are really robust on the Taramps, especially the ones using IGBTs. The power supply sections are the weak point on those generally, but if you do get an output side failure on a Taramps, the power supply survives. So the repair bills on Taramps are super cheap because stuff just doesn't kill itself for no reason. Alright, my soldering iron should be up to temperature now, enough to get rid of this cap. So we are on these two pins here. Let's load up some fresh solder on there first. Might need to blow some hot air actually first. Good idea on these boards. Mr. Sinewave02, how do you feel about jumping on live with me via Discord? Are you feeling that this evening, or are you feeling just kicking back and watching? That sounds like a Pokemon cry. Okay, what's the bottom of the cap going to look like? Oh yes, I see what's happened there. Well, I would bring this up to the camera. However, I've had to turn off autofocus because look what happens if I turn on autofocus. Very frustrating. Configure video, turn on autofocus. It just makes everything blurry. I don't know why, but for some reason it's focusing on somewhere else. Don't know where it's focusing on, but if we can get it to focus on this for a moment. Come on. There we go. So right there, that is the point where it has arced to the trace on the board. Also got a little mark on the side here. Interesting. So yeah, the capacitor casing, through vibration, it's rubbed through the trace and has arced. So now I'm going to have to turn off autofocus again and just manually focus it. Man, this is not the one. This is not the one. There we go. So let's have a look at the top of the board now then, see that damage. Whew. Oh yes. There it is. Not really in focus either, is it there? Configure video, focus. I think maybe if I bring the camera a bit closer down, like about here maybe, then it will look better. Still kind of looks like gas. Yeah, that trace there should continue on to here, but alas, it does not. Crazy. So I think what I'm going to do is, rather than rebuilding the trace up here, there is a risk if I do that, that when I put a capacitor back in, I don't know if this cap is alright. I think it probably is fine. I can measure it and read it. It's just obviously got a hit on the casing, but the actual cap itself, you know, it's not had any stress on it. It's just arced out on the casing of it, but we can check it out. But yeah, if I put the capacitor back, even if it was a different cap, one that didn't have a big hole in it, this is now metal on the underside here, so you risk more vibration damage from shorting back to the trace again. So I think what I'm going to do is rebuild the trace underneath the board and go somewhere else. Like there's a point over here that I can go to, there's a point over here that I can go to. This is not a high current carrying trace. This will just be, as by the looks of it, a ground reference for the auxiliary wind here. So yeah, we don't need, you know, any crazy current carrying trace there or anything like that. Let's, out of curiosity, measure this capacitor and see whether it is, see what its specs are, see whether it's been hurt at all, but I doubt it, because all it's done is it's just acted as a, like, you know, the voltage on the casing here will just be from one of these pins, so no energy has actually gone through the cap material. as far as I can see, really. I mean, even if it has, capacitors are designed to charge and discharge instantaneously. So, you know, shorting out a capacitor to just discharge it instantaneously doesn't hurt it really. Like it, you know, it's doing work. It's using up its cycles, its charge cycles, but it's not hurting it or weakening it any more than it is designed to. Grab my, now will this do a good job? This is quite a big cap, so hopefully my ESR meter can measure it relatively quick. Let's have a look. No energy in it, so just go across the terminals like that. Uh-oh. Capacitor did get hurt. Well, I'll be damned. That's crazy. That's the first time I've ever seen that, I think, on a rail cap. No. Oh, you know what it is? I was probably just shorting out my tester with the capacitor casing. So let's tell it that we want to measure a cap. There we go. I think that's the cap tester. And then like that. Is that the cap tester or is that the inductance tester? That might be the inductance tester. No, that's the inductance tester. It's late here in the UK, guys. Bear with me. This is the cap tester. What am I doing? What am I doing? Okay. ESR of practically nothing. The capacitance 1950-ish microfarads. Okay, and what is this rated for? 2200. So no, this cap is in fact no good. Cannot reuse that. Not recommended. I mean, it's close. I don't know whether that's within spec. Like, it wouldn't be a problem if we fitted it back. It's not got a high ESR. It's not like got a resistance. It's not shorting. But it is a little out of spec. So I need a 160 volt, 2200 microfarad. Which for now, I don't know if I've got any of those exact spec caps, but fortunately for us, we don't need all of the rail caps fitted to test the amplifier. You know, this amp will work perfectly fine without a rail cap fitted for now, so we can just repair the circuit and test everything else with this removed for the time being. Might need to get the heat gun on this again because there's quite a lot of thermal mass in this board. There we go. There we go. So what damage has been happened to the main board? So this trace here is still intact on the back, the rainbow coloured one that obviously took a hit, got some current through it, but on the top here we are missing a trace here, and we also have a resistor here that is completely blown open, or the leg the leg of the resistor is completely gone. So I'm going to try and clean that up and try and get the marking of that resistor. Obviously, I was hoping this camera would actually be decent, but it's really not. It's really not showing up much, is it? Such a shame. Try and get my other camera back up and running. But yeah, you'll just have to take my word for it. I wonder if I can show you it better if I just open my phone camera and zoom in on it. So this is the resistor. That's the resistor which is completely blown open. Missing its leg. And this is the trace that's missing. So yeah, we'll have to do a repair to that circuit there. So let's check this diode here, because that is just after that resistor. Cool, that's measuring alright. Got a couple more semiconductor components in this circuit that I don't particularly trust. That's alright. Got this diode here. That's alright. Okay, now so what resistance is that? We might have an identical circuit somewhere else on the board. We might also have another resistor here that's performing the same task, just in case this one has actually blown open to bits. Okay, this is looking like a 47 ohm, yellow, violet, black. Let's see, are you reading 47? Nope. You are not reading 47. You are completely open by the looks of it. Do we have any resistance on there? Oh wait, 474, that is 47,000 ohms, okay. Yellow, violet, looks like black. This is supposed to be, I think this is supposed to be a 5-band resistor, but it's the last band is missing just because of how it's kind of blown open. So this does appear to be reading within spec. It would be too much of a coincidence if this resistor was a 47 ohm and it's failed to 47 kilo ohm. That would be far too much of a coincidence, sorry. So I shall replace this resistor with a 47 kilo ohm. And this one here, that is reading at 1K, so that's fine. Let's check the continuity of the actual auxiliary wind itself. So on the transformer we have these two leads and it needs to be a dead short, which it is. Excellent. Good news. Alright, so we have a trace repair to do, we have a new capacitor to find and fit, and we have a 47 kilo ohm resistor to find and replace, which are all parts I'll probably have to order or go find, but none of that will prevent the power supply board like this just powering up and giving us some rail voltage to check that all of our repairs are good so far. So I think that's what we'll do now, and we'll see some scary voltage on the terminals here. So I'm going to turn my multimeter to DC voltage mode and just stick the terminals here so we can see the DC voltage. Turn the scope on, connect some power wires. I don't know what the Salt 12 or the rail caps are actually only 160 volt. So the rails aren't going to be as high as some of these other big amps. The Salt 12 is actually a full bridge, so the rail voltage only needs to be half that of its half bridge cousins, if you like. So the rail voltage we're going to see here, we shouldn't really see much above 300. 300 should be kind of like the most that we should see really in terms of rail voltage. The most rail voltage I've ever seen was on a big like 12k half bridge. I think it was like 480 volts, getting on for 480-ish. That was pretty terrifying. Okay, so start off nice and easy with 9.2 volts. Let's probe the back of one of the power supply MOSFETs that we fitted, and let's attach the remote. And let's hit it. Okay, we've got a little pulse there. Okay, so we should be building a bit of rail voltage now, which we are. Why is my multimeter not picking it up? That's strange. Why you are not picking up rail voltage? Oh, there you are now. Maybe it just doesn't do it in the holes like that. Stick it in there, and then I'll stick you in there like that. There we go. Something is off about the multimeter DC reading. The multimeter is reading 28 volts, but on the scope here I've got 10 and 10. So either my scope is off or the multimeter's off. I'm gonna bet that the multimeter's off. That's very strange. I've not seen that before. Why is the multimeter so off? What about if I go down to a lower denominator? 21, 7 and 7. So the multimeter appears to be reading voltage way too high. Although saying that, the battery is actually very low in the multimeter, so that might be why. Yeah, I probably just need to put a new battery in the multimeter. So take the multimeter reading with a pinch of salt here. It's reading a bit high. But regardless, let's do a bit more rail voltage. Okay, cool. Okay, that's alright. That's alright. Okay, we're idling there at 3.6 amps. We have 200 and something. There are some sounds coming from the board that I don't particularly like. I'm just going to take my thermal imaging camera and just have a little peek and just see what's going on. Thermal imager, you can see current moving. So let's have a little look with the thermal imager and see if there's anything getting hot. So we have this pull down resistor getting hot, which is perfectly normal. We have now what we don't want to see is we don't want to see power supply FETs getting warm, because there's absolutely no need for power supply FETs to get warm. They're not driving anything. There should be no cross conduction whatsoever, so there should be no heat in any power supply FETs anywhere. Now 4 amps is quite a lot for just a power supply section by itself. There is a little heat in a couple of these power supply FETs, like only a touch. I don't know if you can see on the screen there. this FET 24 degrees Celsius, whereas some of the other ones down here at 22. However, I did heat gun this area of the board, didn't I, to get the cap out. So it could just be residual heat from the heat gun there. But what I do want to do is just compare the wave shape on some of these FETs. Actually, I need to add the video capture device overhead zoom. I need to add this camera to this view. That's usually there. Yeah, very good. What happened to your Sony phone? Ah, I got rid of it. Wasn't that keen. Okay, wave shape. Alright. Looks the same. How about on the gate? Ah, that's not looking too good actually, that gate waveform there. Not really liking the look of that. If I stop that there and go over to one of these other banks. Like, I haven't ever probed the gate leg of a SALT12, but all the banks are actually exactly the same. But that is a very slow turn off. That is a very slow turn off. But I mean, these FETs, these 7530s are like, do have a lot of gate capacitance. Yeah, it's 9:44 PM here in the UK. I mean, that's not a super great looking gate waveform, if I'm perfectly honest. I would love it if my scope triggered better on it rather than moving around like crazy. What are you doing? Why won't you trigger on it? There we go, that's better. Alright. So the FETs aren't really getting pulled off very quickly at all. That should be the job of the PNP transistor, but without a reference of a known original SALT12 there, I don't know if that's just how it is or whether there is a drive circuit fault. But I mean, both NPN and PNP drivers are working. I've confirmed that. A working SALT12 idles at 8.5 amps. Oh, that's good to know. Well, once I get this connected to the output section, then I'll be able to confirm that. But I can't do that until we repair the auxiliary supply circuit down here that's cooked, because it won't do any class deoscillating or anything like that without that circuit repaired. Let's have another peek with the thermal imager. Well, none of these are getting hot, so I mean, they all sort of, none of them are getting hot, but they're not remaining at their dead stone cold temperature either. So they were sitting at like 22 degrees. They are now at 23. So, you know, there is a minor, teeny tiny amount of heat in them, which I suppose you could expect. Yeah, it just doesn't look amazing, the gate waveform. Right, well that's at 9.2 volts, so we've got to go all the way up to 14, and there's no output section connected, so nothing should go bang really, but it's always a little bit scary, isn't it, when you've got that much voltage sitting there. Just move this over a little bit, there we go. Alright, so let's get this back powered up. There we go. So let's increase the voltage now to 11 volts. Oh, there's definitely some sounds coming from the board that I don't like. I can just hear like little click, click, click. What have we got? 320. So we shouldn't have any more than, well, yeah, we shouldn't really have any more than 320. These rail caps top out at 160 each. But we know that my multimeter battery is dying, so how accurate really is that? Nah, it's not accurate. I'm gonna I'm gonna change the battery in my multimeter because that is giving me the heebie-jeebies. That is seeing like 320 already, and we're nowhere near 14 volts. So that's just a cooked battery in the meter causing that. I mostly just use my multimeter for continuity testing, so having a low battery doesn't really affect my my use for that. Do I have a spare 9-volt battery up here, please? Probably not. I've got one here, but this is probably dead. Is it dead? Yeah, it's dead. Bro, how do I send you a free Kenwood car app? That's very kind of you, my friend. That's really kind of you to want to send me a free amp. You can do if you like. I'm based in the UK, so it only really makes sense if you're also in the UK. There is a Panasonic, no, a Duracell battery up here. I wonder if that's got any charge in it. Nope. That one is also cooked. Ah man, that's a shame. Alright, we'll have to do without the multimeter for now. We'll just have to go by the scope rails. So if I connect up my second probe, connect that to one of the rail outputs, then we'll just have to double it in our head to get the total rail voltage. Okay. Okay, so that's 120 volts. So that's 240. Oh, Jesus! Ah. Where did that come from? There's no output section connected, so there shouldn't have been anything that went bang. Ah, that was right in my ear. Sheesh. Where did that even come from? Maybe there's more. Maybe there's more traces underneath. Oh, fuck's sake. My ear's like beep. I don't think it will come through on stream how loud that was. Obviously it won't because it's all compressed. But that was what that is. It was fireworks night, guys. It's fireworks night here in the UK. So that is absolutely perfect. Where did you come from? I could feel that coming because I could hear like little sounds, but it doesn't really make sense why there would be any sounds because we have no output section connected. All we've got is rectifiers going into the rail caps and just an open rail voltage. So there must be more. There must be more stuff under the rail caps possibly. I might have to watch back on the stream to see if I can tell where the hell that came from. You only have one multimeter. Yep, only have one multimeter. I only need one. Right, let's have a little. Let's have a little watch of the stream back to see if I can see where that came from. Check with the thermal. I don't think the thermal image is going to show it up. Like, it was a very sharp, instantaneous crack, wasn't it? No, it's not the scope ground. Something on the board. I could hear it ticking away a little bit. Yeah, no, there's nothing here. Underneath the board, maybe. No, nothing underneath the board. Yeah, there's no evidence as to where that came from. So where I am at now is I'm thinking, do I just remove some of these other rail caps on the possibility that some of the others are shorting through to the traces underneath? Maybe it was a rectifier. Like, these rectifiers do look like they've taken a bit of a hit, I can't lie. If we have a look at these rectifiers, yeah, I don't think you'll be able to see it on the stream there because the camera's not good enough on this stream, unfortunately, but I'll try and take a picture for you. Smells a little bit sparky over here by these. I think it was the rectifiers, you know. I feel like it was the rectifiers. There's a touch of heat in those, whereas the ones over the other side, what are the ones over the other side here? 24.7, and over this side 25.3, so a little bit warmer, a little bit of heat in those. But what's most interesting is the legs of these. Rectifiers rarely fail, but the legs of these, if I get a picture for you, and I'll show you up close, hopefully, if I can. You don't really expect rectifiers to fail. So that's what the legs look like. So yeah, there has been an arc there, for sure. So yes, those rectifiers are coming out, and I'm going to drop them in the transistor tester. And also maybe give them a continuity test as well before we take them out. I could do without that. I feel like my hearing is going to be bad enough as it is when I'm old without crap like that going on. Does it happen often? Interestingly, no. So that is, I'm trying to think, this year, have I had any moments like that? I don't think. I think that's the first loud bang, like that's the first big kind of boom that I've had in the workshop this whole year. Because you generally only get that happen when you have high voltage that suddenly finds a ground or suddenly finds another rail through a failed component, or you get a drive circuit glitch and high voltage dumps itself instantly somewhere else. That's where you get that sound and that big arc, right? And the way that I repair and check and confirm amplifiers are fixed is I will generally inject a low voltage rail first, check the thing turns on, makes sound. If it does, I gradually increase the rail voltage up to where it naturally sits. And yeah, I haven't had any pops at all for this that I can remember this entire year. That's the first one. I mean, and it would happen on fireworks night, wouldn't it? It'd be just perfect. Okay, that's no good. No, that one's alright. So that rectifier's fine. That rectifier's fine. That rectifier is reading okay, and that one potentially reading okay. So I'm not getting any dead shorts on any of the rectifiers over here. So I'm going to remove them anyway and drop them in the tester just to kind of see what they're reading. Hey, everyone in the Amp Repair group chat. Glad to be of entertainment. I want to watch that back though still. Let's watch it back. I want to watch that back though still. Where was it? Here we go. Somewhere back here. Here we go. Somewhere. Oh, I was on this screen. Damn it. If only I'd been on the other one. So yeah, we can see where it came from potentially. What quality am I even? 720. Let's go up to 1080. Okay, so that's 120 that's volts. Better. So that's 240. Whoo! Actually, that did actually sound really loud. That did actually sound really loud through the stream here. That's 120 volts. So that's 240. Oh, Jesus! Wow, that actually came through quite well. Actually, that's funny. Can you see where it came from? Did it come from the rectifiers? Okay, so that's 120 volts. So that's 240. So that would have been away from there. That would have been that side. Oh! Yeah, it did. Yeah, it came from the rectifiers. Unfortunately, the camera's frame rate wasn't quick enough to catch any of the like huge spark. Really, it didn't really look like much, did it, on the screen here? Okay, so that's 120 volts. So that's 240. Oh, Jesus! Ah, look, what's interesting, I was going to say what's interesting is the constant current light illuminated, but I think that's because I was turning the voltage up. That's 240. Yeah, no, that's fine. Yeah, so definitely came from the rectifiers. So they've got to go, and we've got to fit some new ones. What are these rectifiers that they're using? What are you using? I can't even read the markings on here. Let's get them out first and try and read the markings afterwards. Look at the MOSFET's waveform when it's happening. Alright, let's have a look. I wasn't actually looking at the MOSFET waveform. Oh, Jesus! Can we get a bit of it to react loop? Alright, what's the waveform saying? 120 volts. So that's 240. Okay. So, I mean, it's hard to tell really whether that is actually what the scope was showing. It's a still frame of like a CRT monitor. We definitely have some information up high. Possibly a bit of a flyback on the transformer from it being shorted. 240. Yeah, that's the only frame we get of the scope, I think. Yeah, we just get that one frame of the scope. Playback speed. Let's do playback speed 0.25. 240. That's fucking jokes. You do get a frame, actually, a reflection of the spark on the scope cam. 240. This is where you need like 240 FPS cameras. Wow. Yeah, look at the brightness of that. Damn, that was very bright, hey? Jesus. So scope looking like this. And then the next frame is that weird waveform where, and then we just get that. I wonder if we can calculate from that video how quick was my reaction time to remove the remote pedal. Because, right, that is exactly why, ladies and gents, I love running a foot pedal for the remote, because when you get an event like that happen, if you've had to plug in the remote like with a wire and your hands are nowhere near that, if you have that happen, if I hadn't removed the remote, then the power supply wouldn't have shut off. We just have a bare power supply board here. There's no protection, there's nothing. So the amplifier would have continued to make that higher rail voltage the entire time that the remote was connected. So by having that on a foot pedal, it's a natural reflex when you have something like that happen to like lift up, and like if you're used to using the foot pedal, you just remove your foot instantly. Your foot just comes off the pedal like as a reflex. You haven't even got to think about it. So if you're doing repairs like this, especially with big stuff, well, actually with anything, to be honest, foot pedal, remote wire. It will save you a lot of headaches, and yeah. Yeah, it was definitely the rectifiers, eh? Do you know what I'm tempted to do, guys? I'm tempted to do it again, but film it in high frame rate, in high speed on my phone. Get my safety glasses on, get my earplugs on, and film it in high speed frame rate. But doing that, like, we know that these rectifiers are cooked, so, but I don't know whether doing that can like hurt any of the other. It's probably not going to hurt any of the other rectifiers, but this is a customer's amp. This is not an amp to play with. Do you know what I mean? So although it's tempting to like send it and just kill these rectifiers dramatically, they're already dead anyway, and just send them off properly. Yeah, this isn't our amp to play with like that, but it is tempting. What's your thought on the Salt amps? Wildly overpriced, ancient circuit architecture, but when they work, provided you don't vibration damage them to death, they are very strong, very sturdy. The thing is, the circuit design is very old. As a result of that, most of the bugs have kind of been ironed out. Apologies, internet disconnected there. Probably killed the Wi-Fi adapter with all of that electronics arcing. What I was saying, the Salt amplifiers, yeah, ancient architecture, but because they are so old, most of the bugs and kinks have been ironed out, and they are relatively reliable compared to some other stuff, but they just don't make any sense from a monetary standpoint. They're far too expensive for, like, I don't know what this Salt 12 costs. I don't know, what is it, like 3-4 grand? Like, how many freaking base 15Ks can you buy with that money? And those are also fantastic amplifiers. The latest base 15K from Tyrant is actually sick. It's really good. Yeah, the customer for this is watching. PS Sounds just posted a video about RP Patel's. Oh, sorry, I thought that was like a name of a component or something. RP Patel's van, and it has 36 Salt AKs. How much money do you have to have? I mean, what that's something insane, that is. That's a weapon at that point. Alright, let's remove these rectifiers. I want to see what they read as in the ESR meter. Are you from the UK? I am indeed from the UK. I am. Nice. I've got some guys in the chat coming through with the rectifier model numbers that these should be. I can't read them at the minute. They're a bit too hard to read until I take them out. What are we doing? Can we not see anything on this camera? There we go. The annoying thing is that I saw that I knew that was coming, because as I was powering the amp up, I could hear sounds. Do you remember I was saying like I can hear sounds, something's funky's going on over here, but I didn't listen to myself, and also it didn't make sense. Like there's nothing connected. Like the rail voltage should just be being rectified and buffered, and rectifiers don't go bad ever. So very unusual. Didn't really think anything of it. If I was hearing those sounds coming from the output section with the output FETs fitted, I would be backing off that voltage straight away and investigating. But with a bare power supply board like this, it's very unusual to get that happen. I bet those rectifiers still test okay. Well, that's the thing. Like, they seemed to test alright with the multimeter. None of them were shorted. After that, you should really have a dead short or an open circuit on at least one of them. Because it's not like there was anything laying across the leg or anything that would cause that. Like, that came from within. Or, you know, that was definitely a rectifier being a problem that caused that. I do micro soldering, fix computers, phones with a microscope, etc. Very nice. I've done a bit of that stuff myself in the past. I've done some PC motherboards. I used to do Nintendo Switch consoles all the time. Tiny little chokes on the HDMI outputs, and I did some BGA stuff when I was doing the switches. But generally, my day-to-day work is this big ass, huge amplifiers. Surface mount and through hole, a mix really, but yeah, the components don't really get anywhere near as small as they do in phones, consoles, that sort of thing. But I can do it, but it's just not what gets sent to me generally. I'm known for doing audio stuff. I don't particularly advertise or particularly want to advertise consoles, phones, and that sort of thing. Just because I've got too many amps to repair at the minute. The amps make good money, and I know them really well. So, hello from Canada, love the show, drop a like. Thanks very much, man. Appreciate you dropping in, Charlie. Alright, so guys, do the rectifiers still read fine after that? Probably. Alright, what are we saying? Yep, that appears to be looking alright. 1. Now obviously this is only testing them at low voltage, so 2, that seems to be alright. 3. A little bit of variance there on that one. Only a touch though, it's only a couple off, but the others were identical. 4. Aha! Here we go. Of course it's the 5th one that I test. Is that just not in there properly though? There we go. Oh no! No, hang on a minute. This one is different. It's showing us with a resistance between 1 and 3. 1639 ohms. Okay. Now we didn't get that on any of the others, did we? Let's just drop one of the others back in. Yeah, so these ones we have diodes and we have 12 nanofarads to 76 picofarads. But yeah, this last 5th one here, it took a bit longer for the meter to read it, and it also showed a resistance between 1 and 3, which definitely should not be there. Do we get the resistance? No, this time we don't get the resistance, but we did before, didn't we? Yeah, this is definitely sus. Regardless, these all need changing. But it is curious, isn't it, how occasionally they can look fine. Oh, there we go, we've got our resistance back now. 1 and 3. What's the resistance? In the thousands again? 1500, yeah. Yes, very funny. Shall we have a look at this with the scope? I just want to see really if I can see whether the spark came out of the rectifier or whether it was just across the legs or what really. Now that's not going to be in focus with the camera, is it? That's a shame. Go down. Whee. Yep, there we go. Good evening from Switzerland. Ah, dude, thank you very much for the 10 chuffs. Happy to see you live again. Appreciate the donation there, my friend. That's very kind of you. Hope you're doing well. Always happy to see you on stream. Not really seeing any like cracks or holes in the rectifier itself. It just looks like an arc occurred between the legs. Very interesting. Right, see ya in the bin. These ones can go in the bin as well. But basically, these amplifiers use a mix of common cathode and common anode rectifiers. So if you were paying attention there when I was testing them with the ESR meter, some of them, the 2 diodes pointed outwards, and some of them, the 2 diodes pointed inwards. Different SMPS sections of car amps work in different ways. Some of them use all common cathode, some of them use a mix of common anode, common cathode, and the worst ones because you can never bloody find them if they fail, are the ones that use doublers, which are the two diodes kind of facing the same direction. So the middle leg connects to the cathode of one and the anode of another, and they're bloody hard to get replacements for if they ever fail. The scope is not connected to a capture card. It was connected to a capture card, but not this stream. The last stream I did, my capture card failed. As you can see, the HDMI is still actually connected to the scope, but unfortunately the capture card is toast and I just haven't got around to putting a new one in yet. I do have a new one here. I've got Elgato Gaming HD 60 Pro. However, as I mentioned at the start of my stream, very frustrating, the capture card that I've been using for years is a cheap, unbranded one from China. It only does 1080i, not 1080p, but that doesn't make a difference for the stream really. The stream quality is what it is fine. And I've been loving it because it has practically zero input lag. So what you capture into the capture card in OBS, it's practically bang on, a couple of milliseconds here or there. These capture cards, any of the branded ones I've tried over the years, supposedly meant to be better, horrendous amount of input lag. Like, one of them was 4.5 seconds input lag. So when I was streaming, I had to delay every other source, camera and microphone, by like 4.5 seconds, and it was just an absolute pain because, like, when I'm streaming here and I'm moving this board around my desk like this, I'm looking at the screen on the PC to confirm that I've got it in the right place for the stream. And if it's 4.5 seconds behind, I'm having to move it like this and be like 1, 2, 3, 4. Oh wait, hang on, let me move it a bit this way. 1, 2, 3. That's not the one. It is not the way. This one here that I'm going to fit, I think it has a bit of an input lag, maybe like, I don't know, 0.7 of a second. It's still kind of brutal to work with, but what can you do? Anyway, yeah, so I guess we've got to order some parts for this now. I could actually power it up again now that the rectifiers are out, because we don't need to be rectifying all banks. But I think give my ears a rest for tonight, just in case anything else funky happens. But there's some crazy voltage on there. What next? We are going to be looking at another big-ass Sundown amplifier. So this is a Sundown Audio SALT12. Massive, great big thing. And I've also got a Sundown NS2 to look at as well, so we can drop that on the bench. Ooh, stay, good little camera. We can drop that on the bench and give that a crack, see what's going on. The NS2 is the complete opposite failure of this SALT12. This SALT12 had a failed power supply section with an intact output section. However, the NS2 has a failed output section with an intact power supply. Buy another Chinese one. I haven't been able to find one because, like, they're not branded, so I don't know what to search for. I just bought it off eBay one time years ago, but like trying to find the same basic model of that again, either from a brand or unbranded, I haven't really had any luck finding one. And, you know, in my head I'm like, oh, you know what I'll do? I'll buy a branded one. I'll get, like, you know, a decent one, buy a, you know, expensive one. And whenever I've done that, they're bloody rubbish, or that they have this horrendous input lag. And I'm like, oh man, this is not good for streaming. I get it, it's fine if you're capturing gameplay just to a video file. It doesn't matter what the input lag is, but when you're streaming, it's not the one. 40 drive transistors, absolutely ridiculous. You see all this? All this could be replaced by a couple of drive ICs. Why are you discreetly driving MOSFETs in 2025, bro? What are you doing? 25-year-old ass design board layout, freaking. That's car audio for you. Right, let's move on to the next one then. NS2. Fucking hell, man. He's a heavy man over. Oh, he's backwards on the bench. I have a Ugreen USB capture card. I need to look if there is any delay. Probably is. The Sundown Team 10K got rid of all the transistors and have drivers now in the power supply. Well, that's good to know. About bloody time. Right, Sundown NS2. This one has a blown output section. Now, the problem with these amps, repairing them now, is that these amps use in the output section, the MOSFETs they use are FDA 20N50F. FDA 20N50F. Now these circuits are incredibly fussy. They're very, very sensitive to the total gate capacitance that the drive circuit is working with. So these FETs aren't available to buy anymore. FDA 20N50F, if you can buy them, they're like £8 each because they're like hard to buy, or they don't exist anymore from suppliers, etc. So you can't buy them, you can't use them anymore. So when I have tried in the past, without knowing that these circuits are super, super fussy with the exact gate capacitance and the exact FET gate drive characteristics, I've tried subbing in different FETs with very, very similar data sheets and similar specs. You know, they should work on paper. They don't. They just freaking explode. And which is you see the explosion in my stream starting, right? See this screen right here. You're going to lose my mic in just for a second, but watch this clip. Right, that explosion was a big Korean 10-12K half bridge with some, I can't remember what I used. I feel like I used 24 N50s. Very similar on paper, but no, it doesn't like it. So what I've had to do with this one is I've ordered parts for this one, but I've had to really, really go through data sheets with a fine-tooth comb and pick FETs with as close to the original part input capacitance, total gate charge, on-off delay timings, etc., to try and allow this circuit to remain happy. Now you can modify the drive circuit a little bit. You can change the gate resistor value, which will bring things in and out of stability with these type of circuits, where you've got so many FETs in parallel up and down the board. But you know, I don't really want to make modifications unless I have to, because the more mods and the more things you change, the more chance that you throw things out of the perfect harmony balance. So if I can find some FETs that are going to work with the original drive circuit as it is, then that's what I want to leave it as, you know. I have two blown XS 16K amps. 16Ks, I can't remember. I don't think I've seen those. Are they using this old ass Korean half bridge design or whatever it is? So let's get this out of the case and see what we're working with. Did somebody say ChatGPT time? No. Absolutely not. Anyone in the electronics field will know from asking anything electronics related to ChatGPT that it has no freaking idea what it's talking about when it comes to actual in-depth electronics questions, because there isn't really a lot of that information out there on the web for your specific application you're going to be asking it about. So its training data is just spewing out nonsense that it's read from forum posts that are probably incorrect in the first place. No, ChatGPT does not do well with electronics. Terrible time. Use ChatGPT to come up with a quick bedtime story with some custom characters and a custom story, like, fine. Don't use it for anything electronics related like that. No good at all. Thank you for the live streaming. The big Sundowns I've thoroughly enjoyed. Great. I'm glad that you've enjoyed them. It's been dramatic so far. I've had good success with the Sundowns recently. I've got a pair of NS1s over there on the bench complete, and I've just completed a SAZ 5000 and a couple of SFBs. So yeah, it's been going well with the Sundowns. Now these FETs get stuck to the thermal tape. The thermal tape in this stuff, this yellow stuff, is kind of squishy like a foam, and if you just pull the FET away from it, then you bring half of the foam with it. You like rip the foam in half. So what you do first, is it going to zoom in now? What you do first is if you just wiggle the FET side to side to break the adhesion, and then put it away, then you don't rip the thermal stuff. Because this isn't single-use stuff. This thermal tape. It's perfectly reusable provided it's intact. So doing this just keeps it intact. There we go. Oh, there's only half a MOSFET there because that has been blown to smithereens. I'll try and show you that on the microscope in a minute. It's absolutely obliterated that one. What's good? 13 BTR, what's good, my friend? Man, good to see you here on the stream. Hope you're doing well. What's happening for you today? What's happening for you this week? I forget, I haven't had them open in years. One had a blown output side, and I replaced the FETs, and now I only get sound when the RCA is in the slave port with that switch on. That's very unusual. That's not anything output section related. Like, if that was actually a genuine fault, that would be an issue with the preamp circuit. When you go in the slave port, you bypass the preamp circuit practically entirely, and you're just injecting RCA signal almost directly into the drive circuit of the amplifier. So if you don't get anything through the normal inputs, then you could have some damage to the preamp circuit, which is kind of unusual unless you shorted out something to the RCA. Like, if you accidentally touch the speaker wire on the RCA, then yeah, that might be a reason that that's happened. But that's very unusual. Usually it's just a bad master-slave switch. Like, give the master-slave switch a proper good clean. It could just have bad contacts on the master side. So give that a proper clean. Could just be that. Just waking up with a coffee, getting ready to go to work. Waking up? What time is it there? You must spend so much on transistors for repairing these amps. When fixing house amps or active monitors, you only really have to buy a pair of transistors. Yep. So, like, to do a full rebuild on one of these amps, to do the power supply and the output section, you're probably looking at like £250 worth of MOSFETs, perhaps, maybe more. And imagine you do that. Imagine you spend £250 on parts, you repair it, it goes back in the car, and then something that's weakened from the repair that you didn't replace fails, or something you missed happens, or whatever, and then everything blows up again. You just lost £250 worth of parts. You can't get that money back. That's just parts that have just exploded, money that's just gone bang, it sucks. $4.30, I work nights, fair enough. Makes sense. This LTT screwdriver is supposed to have a really strong magnet on it, and it is quite strong, but it's not as strong as I'd like. I'd say try and get more DJ gear in. Yeah, maybe. I'm not super into repairing mains equipment, but that's just because I'm not set up for it. Like, my entire business model and bench setup is just centered around doing automotive repairs, ECUs, amplifiers, that kind of thing. So while I do repair some main stuff, it's not what I generally advertise that I do, and I don't particularly like doing it just because it's a bit of a faff. Just, you know, if I built myself a second workbench that was dedicated to doing mains stuff that had a very different kind of power supply setup, you know, big variac or something, you know, along those lines, with a bunch of other stuff, then that would be fine. But I quite like working on car stuff. Kevin, yes, I have heard that as well. Very weird. It's 5:33 in the United States. No, it's also in the afternoon, but he's working nights, so it's the start of his work day. Coming through with a 20. 13 BTR, thank you very much for the 20, man. Appreciate you as always. You're always dropping off. You're always dropping little tips here and there, man. Thank you very much. I hope you have a great day at work. Thank you, man. How much of the tip does YouTube take? I've got a feeling it's something like 30%. I don't know. I know that it takes like more than you would think. You can Google it. How much does YouTube take from Super Chat donations? It might not be 30%, but I think it's higher than you think. It's like, oh damn, like if someone donated you £100, you might see 80, something like that. Maybe it's 20%. YouTube takes 30% of your tips. There we go, there it is. From Mr. Holden, yes, 30%. Brutal. What about FDA 20 N50? So very cool. Don't think we have those in the UK. How much are they each, Chris? Because I think that is the original part that this amp uses. More screws in this. Okay, no worries. Matt, what's up, my dude? What's up? How you doing, my friend? Good to see you here, bro. Been a while. Okay, screw there, screw there. My ears still hurt a little bit. Cool. That looks like all the main screws out. So, with all the screws out and all the clamps off, this should in theory, pull out now, provided it's not soldered. Sometimes these boards are soldered. No, it doesn't look like it is. We have a bit of movement. Do need to remove this LED strip though, annoyingly. It's on the heatsink here in an annoying way. Oh, what's happened to my live chat? Oh, there we go. Yes, creators receive 70%, so that's crazy. Think about, I don't know if any of you have seen any or watched any live streams where, you know, big donations are coming in. Like, I was watching a Jimmy Broadbent stream, for example, one time, and it was just a constant hammering of like big donation, big donation, big donation, like £100, £50, £100, 20, 50, 100, 200, 500. Imagine how much money YouTube made from that one stream. I think that was his first stream back as a dad after he had his little baby boy, and yeah, it was just he couldn't do his stream because donations just wouldn't stop. So he couldn't do what he had planned because there was just donation after donation after donation. So just, yeah, YouTube absolutely raking it in. I don't know how that compares to Twitch. I don't stream on Twitch, but is it similar? Does Twitch take a similar cut, or is it less? Just going to desolder the ground wire here. Twitch take 50. Jesus, that's crazy. Making YouTube look good up in here still. Next time I'll just PayPal you. Yep, that works. That works. What are we stuck on? Stuck on something. Oh, there we go. There we go. She's out. Right. Output section board. There's a bit of a thing though, because donating on stream, although YouTube takes 30%, I imagine that there's, from a creator standpoint, there's a bit of an incentive to want people to donate on the live chat, just because of how it comes up on the stream. So it might then encourage others to donate. Do you know what I'm saying? So like if someone was streaming on YouTube, they got like a bunch of viewers, and like a donation comes through in the live chat, then other people watching see that, and then they might think, oh yeah, that's a good idea. Whereas if it's just coming through like via PayPal or something like that and doesn't not really seen on the stream in the same way, then the streamer might actually end up getting less because less donations come in, even though YouTube takes a cut. So yeah, it's a bit of swings and roundabouts. I can see why they do it. Alright, well let's get all these FETs out. So these are 20 N50F, and these are no longer available. So I have ordered some, from what I can see, as compatible as possible. And I did a lot of back and forth with a couple of guys in the amp repair chat about what they've used and what's worked for them, because these are not cheap. So if we can avoid killing all the new FETs just because they're not happy in the circuit due to the gate capacitance differences and stuff like that, then that would be great. So this Sundown NS2, this is one of the more scary ones to repair, because this is a half bridge. So the SALT12 is actually a full bridge amp. So the rail voltage is lower, whereas this NS2, this is a half bridge. So the output FETs in this are 500 volt rated parts, and the rail voltage itself will be definitely kicking up around the 450, 480 volts, and 480 volts isn't super high voltage. You know, it's not high voltage. When you talk about high voltage, you're talking about like thousands of volts, like 10 kilovolt or even 5 kilovolts. That's getting into high voltage. So 480 isn't really high voltage, it's still kind of low voltage. But the difference is that this is 480 volts with a lot of current behind it in form of the rail capacitors. And even when the amplifier is up and running, to be honest, there's a lot of current there behind the 480 volts. But the energy stored in the rail caps is, yeah, it's kind of frightening for that much voltage. Can I join that chat? It's not my chat, so I can't say yes or no. Yeah, it doesn't belong to me. It's part of a Facebook group, I think. I think I get the impression. I don't know. Obviously, RTS. I think by the sounds of it, you do amp repair. By the sounds of your name on YouTube, and I probably maybe know you anyway. But I suck at remembering people's YouTube usernames and who they are in real life. Yeah, if you do car amp repair anyway, then I'm sure they'd welcome you in. Why do you use such a large soldering iron? Doesn't that damage the traces? No. So the reason I'm using a large soldering iron is because we are working with very large components, very high thermal mass PCBs. This is a 200 watt Weller iron from the 90s. And no, we're not damaging the traces at all. They come out looking factory when this is repaired. The reason that they don't damage the traces is partly because the traces are so big and so thick and have so much thermal mass that you actually need an iron like this that's really big and powerful to actually get any heat into the trace. You'd actually run the risk of damaging the trace if you were using an underpowered iron that just wasn't getting it hot enough and therefore wasn't desoldering things properly, and you end up pulling at the board and pulling at the vias, and then you pull the traces up and you pull the vias out and stuff. That's not what you want. Generally, my motto for soldering is you want high energy, so high temperature, low duration. Yeah, if your iron is powerful and very hot, then you can heat up the area that you're trying to heat and desolder the components you're trying to desolder without having to keep your iron on the board for ages, getting all that heat soaking through the traces, through into other components, potentially melting plastic parts, capacitors, etc. High heat, low duration. Keep the heat concentrated in the area that you're working on, and that gets the legs desoldered without as much risk of the heat transferring into the MOSFET itself or elsewhere onto the board. If I could, I'd run an even more powerful iron. You know, here I'd run like a 500 watt iron or something like that, and you'd basically touch the pads, the solder would melt near instantaneously, and you just pull the FET out, and the heat hasn't gone anywhere else on the board. Yeah, I did change my logo recently. That makes sense. But like these things that I'm working on here are not your typical, they're not your typical like laptop, mobile phone, electronics repair kind of thing. You know, you'd never use an iron like this with that kind of electronics. This is really high power density, really high current stuff. Like, yeah, this isn't what most electronics people are working on. What's the car behind you? Also, so that is it's a PT Cruiser model RC car. It's by a brand called New Bright. It's from like the early 2000s. So the reason I have that is because I had a series on YouTube, I think it was a couple of years ago now, called excuse me, called Boom or Bust, which is prototype testing subwoofer enclosures but on a miniature scale. So everything apart from the dB readings, of course, because that's the controlled part. Everything else about the testing was scaled, so the frequencies were scaled, the volumes were scaled, etc. And it actually worked really well. The scaling is correct. Audio sound is just fluid dynamics, and it does scale pretty well from 1/6 up to real scale. It works really well. And season 1, I built my own test cabin for that video series. So I built a vehicle cabin in a 1/6 scale from wood and plexiglass, whatever it's called, clear acrylic plastic for a window. And that worked really well, but the test cabin I built was, firstly, it didn't look like a car, obviously, it was just a wooden enclosure. But secondly, is it was too strong and rigid. It was basically like an extreme SPL cabin that had been concrete built and like welded and everything. So the dB scores were inflated compared to what you would expect to achieve in a normal kind of stock vehicle cabin, for example. So for season 2 of this Boom or Bust series that I was doing, I wanted to have a test cabin, a test enclosure volume that more closely resembled oh, I've left the MOSFET in there, that more closely resembled an actual vehicle cabin. So yeah, I managed to find a 1/6 scale PT Cruiser, which is the scale that we're working with in the testing. And I was like, great, this can be my new test volume, because it's obviously made out of plastic, which is a lot more flexible. So I was thinking, man, maybe the plastic build of this PT Cruiser RC car would more closely resemble how a real vehicle sort of flexes, you know, the body panels flex, and there's leakages, you know, and stuff like that. But in my preliminary testing with it, it turns out that this PT Cruiser RC car is actually way too leaky. The cabin barely, it can't hold any pressure at all. It's basically like the subwoofer enclosure is just sitting in a field. Like, yeah, the cabin of this PT Cruiser has absolutely no bearing on the audio whatsoever. You don't get standing waves built. It's got no Helmholtz mode. It doesn't really have a quarter wave mode. All the pressure just leaks out, and it was so bad that in season 1, using a specific test enclosure and a certain amount of power, so we put 15 watts into the test aeroport box, which is just a little aeroported box. And in season 1, in the test cabin that we built for season 1, we were doing 145 dBs. And that's real. There was really 145 dBs worth of sound pressure at what was it? 100. What frequency was it? 100. At 150 hertz, there was 145 dBs worth of sound pressure in the test cabin. However, with the PT Cruiser that I've got behind me, there was 115 decibels. So yeah, it's completely not usable. Doesn't reflect what you would expect from a real vehicle cabin. Single 12 on scaled 500 watts, maybe a 130 something, 135 maybe. Yeah, but it didn't do anywhere near that. So what I have to do is I have to make some modifications to the PT Cruiser. I've got to seal it up, basically. I've got to try and get it as close to how sealed a real vehicle cabin is, and then it will work. But I just haven't had the time. There's a bit of a back burner project that now is more work than I thought it was going to be. Maybe you could seal up everything in the cabin except for the rear hatch. Yeah, basically that's what I intend to do. I just need to get around to doing it. But I still want it to look good, you know what I mean? I still want it to look legit. The driver's door needs to be able to be opened as well for the testing, because we test in proper droppers format, which is a vehicle SPL testing it's a competition format called proper droppers, and for that you don't have to, but it makes sense to have your driver's door open, SPL sensor on the passenger headrest, and that then turns your vehicle cabin into an acoustic chamber with a Helmholtz mode. You tune the Helmholtz resonant frequency of your vehicle cabin with how much your door is open or how much your window is open, and it drastically inflates your SPL score compared to having the car sealed up. But yeah, it's a really cool series that I did, and I really love it. I love doing those videos, but I felt like it needed some tweaking for season 2, and the tweaking was more than I had anticipated, and I just haven't got around to it yet. Yeah, I did. Yeah, Boomer Bus season 1 was basically proper droppers. Yeah, we tested the same 4 frequencies. We tested, it's basically the same 4. Proper droppers tests 20, proper droppers tests 20, 25, 33, and 40. And for Boomer Bust, I tweaked that slightly because I felt like, realistically, who really needs to play 20 hertz? I know that it's cool, I know that it's windy, but you know, for an actual musical system, someone listening to actual real music, you trade off some higher frequency response by trying to build a system that plays 20 hertz. So I started at 25. So yeah, for Boom or Bust it was 25, 33, 45, and 60. Obviously those frequencies were scaled, so in reality it was 150, 198, 200 and... I can't even remember what they were, but it was times by 6. So yeah, just times the frequency by 6, and that's what you get for the scaled frequencies that we used. just desoldering all of the holes here for the new MOSFETs. Now we can't fit the new MOSFETs yet. We're nowhere near fitting new MOSFETs. This amp will need a lot of drive circuit repair work doing. Yeah, I'm just preparing the output section ready for that. Yeah, if you like the sound of that, if you like the sound of that video series, then after this stream has finished, which will be very shortly because it's 11 PM, which is my bedtime, go watch it. Search YouTube, Bear Vids, Boom or Bust. There is, I think, 16 episodes in season 1, and yeah, it's really good fun. It's a laugh, and you learn something about enclosures, you learn something about acoustics, you learn something about how quarter wave and Helmholtz differentiates from each other. You learn a bit about cabin acoustics, you learn a bit about different enclosure designs, 6th orders, 4th orders, horns, transmission lines, regular ported enclosures. You learn about impedance sweeps, impedance rise. There's so much you can learn from watching Boom or Bust, and it is, in my opinion, pretty entertaining. But yeah, I think that's where we'll leave it for tonight, guys. And we'll continue the NS2 repair in a later stream at some other point. We'll have you streaming the rest of this week. It's Thursday tomorrow. It's my birthday on Friday. Yay! More oldness. So I won't be streaming. Probably won't be streaming tomorrow. Probably won't be streaming Friday. Unless I decide to do a birthday stream, but I don't know what I'm doing on Friday yet. I might try and do something in the evening. So yeah, we'll see. And then a weekend, yeah, we'll see. It'll be a spontaneous stream. So click subscribe, click the bell, because genuinely I stream spontaneously. So if you want to jump on the stream when I'm streaming, you probably want to be notified about that. So how is my son? I do not have a son. I have a daughter. She's good. She's very, very funny. Absolutely love her to bits. Absolutely hilarious. Was the NS2 overdriven? Yes, I think the NS2 failed because it was the subwoofer failed. Yeah, the sub blew, voice coil shorted out, killed the output section. That's what happened in the NS2. I printed an enclosure meant for Boom or Bust, used the same speaker, but in my SPL meter, for whatever reason, it wasn't working at the time. I never got to test it. Oh, that's a shame, man. Be cool to see if you could test it. My birthday is the 23rd of this month. Nice. Bunch of November birthdays here. Thank you very much. 220GP, appreciate the kind words, man. Thank you very much, man. Appreciate that. Hope you're doing well as well. And yeah. Hope you guys enjoyed the fireworks, because it is fireworks night in the UK. If you've just recently joined the stream, go back in the stream a bit earlier. We had a big explosion. It was very loud. Maybe you could put the microphone on the outside windshield with a hole and seal it up. That way it won't take up any interior space. Good point, Jason. The problem with that is it then isn't technically proper dropper spec, and I want to try and keep it as close to proper dropper spec as possible. The solution would be actually just to remove the pressure sensor from the the SPL sensor itself. Is quite big, but the actual sensor itself on the board is very small, so I could just desolder that and run some little extension cables. Hopefully it wouldn't mess up the calibration. I don't know, but that would be a solution for that. But I'm not too bothered about the sensor taking up cabin volume, really, because you can have someone sitting in that seat and it will take up cabin volume. We also don't have anyone sitting in the test cabin when we're testing, because obviously it's tiny, obviously. So yeah, I'm not too bothered about that. As long as it's consistent between tests, that's what I care about. My guy just comes up in here. Louis? Bolivia! Sick. How's it going, man? Thanks for jumping in the stream. Appreciate you. I assume from Bolivia. How's it going in Bolivia? Why do old school amps use a lot more voltage than cheap newer amps? Newer amps, they don't use more voltage. Old school amps, they don't. You can't use voltage. Voltage is like a pressure. Voltage is like pressure coming. You can use current. You can't use voltage. I'm not sure what you mean by that question. Maybe why do they prefer higher voltages? They don't really. Older amplifiers tended to be less regulated, so you could get more power from the amp by going up in voltage, but that made them less reliable because you're pushing all the components inside closer to their breakdown limits. But yeah, they didn't really prefer more voltage or anything like that. They drop voltage more. So to drop voltage, you draw current. So the more current you draw, the more voltage drops. Now, older amplifiers generally were less efficient. So to clamp 3000 watts at the speaker terminals from an old amp generally would require more current than a modern amplifier because they're less efficient. So therefore you would see more voltage drop with an older amplifier on the same electrical system compared to a newer amp. So that's why. Just efficiency, really. Alright guys, that's it for tonight. I'm out. Take it easy. I'll see you when I am another year older next week probably. So enjoy your weekend. Catch you next time.